So welcome back. We are now, as I promised, solving some array problems here, basic array problems. As if you have the chance to check my previous videos, we are covering arrays data structure in general, uh, coming from MIT lecture standpoint, where uh, the first data structures that they cover are arrays and linked lists, and the majority of the problems that they tackle in the first class of that specific lectures are related to arrays, specifically pick finder and some other types of problems that they use as toy problems. They call it toy problems. So that's it. Now we already did merge sort array on the channel, and I will cover these other problems here and try to cover these other problems. And we are going to learn how to think and find different solutions and the trade-off of our thought process on the outcome of these solutions, basically. So each technique has a trade-off. Each of these problems can be tackled on many different ways, and we need to at least to know that this is possible. And that's my goal here. Is not, something heavy or something that, or I'm trying to show that I know something, because my goal here is actually to fixate the content and to share what I'm learning and how is my studying process, and how it's changing and shaping my thought process. All right, cool. Let's get started. And let's see, just remove elements. Even integer array nums in an integer val, remove all occurrences of val in nums in place. In place means in a non-mutable way. We can't mutate the array, basically. The order of the elements may be changed. Then return the number of elements in nums which are not equal to val. Consider the number of elements, so we would need to return different all, right? We're gonna loop, so it's going to be on by any chances that we know. Uh, and return that it's different to val, and consider the number of elements nums which are not equal to val to be k. That's k. Um, is equal length. This length. Um, and basically here we will have change the array nums such in the first k elements of nums contain elements which are not equal to val. The remaining elements of nums are not important as well as the size of nums. So regardless of the order here, we just need to return the items that are not equal to 3, for example, in this input. And that's an example, and that's the outputs that we need. And we can start thinking about the problem. So first thing here, we work with arrays. My first thought process here will be, the brute force solution here for this problem. I was thinking in something like this. So my thought process was, I'm gonna run through it here, was basically um, um, I so how I thought about this problem here. Basically, the brute force, in my opinion, would come over in a solution that would look like something like this. You have 2 pointers. The first pointer will start here at I, and the second pointer will start at j, which is I plus 1. And whenever I start looping, I'll have a counter called k, and then for the nums length, we're gonna loop, and if nums I is equal value is 3, for example, then we're going to iterate through the whole array again, and basically reorganize the array based on that. So how is that done? We follow the nums length where j is I plus 1, so we're going to start here, and then we're going to say that nums I is equal nums j, and we're going to increment the counter for each for k plus plus should be here actually. We're going to implement the count inside of this part here, and then we're going to do the other for loop. So if you find a value that is equal to the value, you implement the counter function that will sum up here one more occurrence for that specific count for that specific value that is expected to be not to be in the array. So you're gonna count that. So what is k actually? So also yeah, so k is different. Okay. So I could do if nums, and I can just have an else condition here. Else we can say k plus plus, right? Yeah, so that's it. Um, so yeah, we have k, we have a counter, we run on a first loop here. We're gonna check if the nums I is equal value, which is 3. If it is equal value, we don't need to count it. Um, and we're going to basically remove it from the list. How I'm doing that, I'm looping through the whole array again, or at least from j, where is I plus 1, because we are already here. And what we're going to do basically is say that nums I is equal nums j. So basically what's going to happen here, uh, nums I and j, and then I'm gonna say that nums I is equal j, and then I'm gonna increment both, and then I'm going to increment both, and then I'm going to run here again. Is it different? No, is it different? Is it? Okay, so then I'm going to loop again, and I'm going to have j here, which is going to be I plus 1, which is not the case. So we could have a condition here to avoid any crash, something like that. But that will be basically a brute force solution for this problem. Here we'll take like O of m m x n, basically that will be something like this, because each time we iterate through one item, and basically we have to run through the loop again, and it could be m x n times. It will never be O n squared, I think. um, and if m is equal n, and then O m n squared, basically. So in that case, we would have n squared, right? I don't think it's possible because it will never be n, but it will be approximately n squared. It could be, but I would say mx1 for this one. I might be wrong. I would research later. Down the board. So let's remove elements. It's one, solution one, brute force. Let's call it brute force. let's go to an optimal solution and the result. All right, cool. That's all we need here. We would like to have this, and we also have k, which is the numbers that we need to return. And with that being said, what's the best way to find to remove elements from this array on an optimal time here? Um, um, value which is 3 as well, right? And what we're going to do here, we're going to iterate through this array. The first thing we need is an index. It's a very non-intuitive way to iterate through the array, but as long as we understand now how this works, we could apply it to future problems, for example. Uh, so first thing that we're going to do here, we're going to check if the item is equals to the value that we expect here. So in this case, we're going to check is nums I equal value. Uh, different value. That's what we need here. Because if it is what we want to do, um, we're going to say that nums k is equal nums value, basically. That's what I'm saying. It's not a very intuitive way because you kind of need to think back to front here. Uh, and then you're going to k plus plus here. What's going to happen is it's going to say that nums is different value. Um, it's different value. No, it's not. So what is going to happen here is going to go to this place here. And then if it is, it's going to say what the program is saying is nums k is equal nums y, and then it's going to plus plus. So that's going to happen on the second iteration. And basically what's going to happen here again, we're going to iterate again, we're going to iterate again. And then hey, nums i's is different value. Nums I is different value. Yes, it is. So it's okay. And then you iterate again. So like it's two pointers that always keep on check of the next item on that next iteration that is going to have uh, the specific change that we need that will match the difference between value. And when that happens, it starts, uh, you know, iterating back to front here, like from K to Y until it basically, you know, kind of, you know, swaps the whole array items that we needed, for example. So let's give a more complex example here. We have this example when we do the same thing here. We're going to come back here. We're going to say we have k and I at 0, and our value is 2, right? And we're going to start iterating here, like, oh, is it different of value? Yeah, it is. So we update it and plus plus. Is it a different of value? Yes, it is. So update and plus plus. Oh, it's not different of value. So we don't update and keep the loop in the loop, basically. So is it different of value? No, it's not. And then we have the window that we need. It's kind of a sliding window here. Uh, yeah, because as you can see, it's kind of a sliding window. Where's my console? Um, where we have this window here of from K to I, where we will start iterating back. So whenever that happens, I'm going to say that nums k is equal nums y, right? And that that's where my window starts changing, basically, and I will iterate from the front of the array from K to the back of the array here, uh, whatever you would like to consider. Um, but what's happening, I'm going to iterate like refilling the array on this window here, basically. So what's going to happen is equal to, so numsk is equals to, oh, that's k here because we iterate through this path. Yeah, to this here. And, oh no, yeah, that's two. That's, yeah, it's here. So yeah, so we're going to start changing here, and then we're going to say, yeah, k plus plus, right? Right, bro. And then we're going to go back again here, and I plus, and is it different of value? Yes, it is. So what's going to happen? We're going to put nums k is equal to nums y, right? Okie dokie, then we plus plus, and then we come back here. We go to, is it different value? Yes, it is not. Is it different value? Okay, it's not. So what's going to happen? Nums k is equal. Create a window here from the previous iterations where we cover where uh, value was present and where it should not be present, and what we can do is from that as a linear iteration, we could kind of do the following here. If you see an underline here onwards, we can say that, for example, this is going to come this way basically. So what's going to happen is this is going to be moved to this place here, and then we're going to have something like this, right? Uh, if that makes sense. That's our process here. We're going to break these two things here and remove this basically by shifting left, basically. That's what we're doing here. And for that, we just need the window and its linear time, which is great. So, okay, let's start doing this basically. So then let's cover the loop here, though. What's going to happen here? So we have k, we have I, k is 2 here, the first two here, where it started counting where the value was present, and uh, then we have this window here, and then we're going to say, is nums y different value? Yes, obviously. So nums k is equal to nums y, so we're going to say 3. We remove the first two, say k plus plus, and then I goes to the next item, and then we're going to ask again, is it so it is. Okay, so then k plus plus, then we ask the same thing again. Oh, it is. Yes, it is. Then we're gonna say k plus plus. Okay, and then we're gonna say again, oh, is it? No, it's not. So I think now we have our solution here. The problem, but it uses a sliding window. It's just a 2 pointers, but it's kind of is a sliding window here, right? Because we have this window, we have two indexes, and it goes, adapting as it goes. So let's code this actual problem here. So first thing, we need a counter, which is going to be 0. We have a for loop for I is equal to 0. I nums.length I plus plus. Then we will return k because that's the amount items that we need to return there. Then I'm gonna say if nums I is different value, what's going to happen? Nums k is equal to nums I, and then I'm gonna say k plus plus um, equals nums I. Yeah, that's it. That's my failure. All right. Let's see what happens. Oh, that's failure. Um, let's see. There's a typo there. Let's submit it. Okay, it's gone. That's the first one. Anyways, guys, thanks for watching. Keep tuned for more videos. I'll be probably also reviewing the MIT courses lectures soon. And I also have um, this article that I would like to read with you guys. Um, at least the first paragraph and cover some of these topics here, but that will be later. So, anyways, really, really glad to share that with you guys, and let's keep making progress.